Hi everyone! We now have completed the first phase of this module, where we went through several exercises to familiarize ourselves with actions and their specific requirements. In particular, we learned that actions are often non-deterministic. For example, every time we ask for an input from a user, they may answer differently, which means we need to retry actions until certain conditions are met. We have also seen that actions can fail, which means we need to control when the action is evaluated in order to handle exceptions safely using try. Finally, something that we haven't really covered, but we can probably guess, is that actions need to be asynchronous, so that we can execute them concurrently on a thread pool, similar to how the Scala features work. Okay, so the goal for today's lecture is to design an interface for actions in Scala, so that they satisfy these three requirements. In the previous exercises, we discovered that byname parameters play a crucial role. For example, they were required to implement a generic retry and on-error functions. Additionally, we saw that byname parameters were used in the constructor of try and future. So we may not know how to encode actions just yet, but it is likely that the action type will need a constructor that takes a byname parameter. So let's start with that. We also know that the action type will take a type parameter, because each action produces different results, such as an int, a string, a user, or something else. So we'll use the type parameter to encode the return type of the action. So that's pretty good. We have already made some progress, but we don't really know any more than that about the Action API. So let's try to turn the tables and ask ourselves, what will be the simplest possible interface that matches this constructor? I'll let you pause the video and think about it for a minute or two. In the evaluation lecture, we saw that a byname parameter is a convenient syntax for a val function without parameter. And in the val versus def lecture, we saw the equivalence between a val and a def function. For example, here, two versions of greeting, a function with no parameter that prints hello to the console. The first one is a val function, and the second one a def function. So the simplest possible interface that matches this constructor is a trait with a single method that takes no parameter and returns an A. Let's call this method execute, because it triggers the evaluation of the action. Now, how are we going to implement the constructor? We need to create an instance of the action trait, which means we need to implement the execute method. The only way to do this is to access the byname parameter, which will be re-evaluated every time execute is called. Okay, so let's compare the three implementations of greeting: val function, def function, and action. We see that they behave exactly the same, as in nothing is printed when the function or action is created. We only see a message when we call the function, and we can repeat this as many times as we want. Now, you might wonder why we define actions with a trait. This seems to be a more verbose solution with no real benefits. There are actually a few reasons for that. First, we can offer a rich API by implementing methods directly on the action trait, such as retry, on error, and maybe parallel for executing the action in another thread. This way, we can use an OOP syntax to build complex functions from simpler ones. For example, action.retry.onerror.parallel. Another reason is to provide better documentation. We have seen that actions have different characteristics to FP functions, as in they are non-deterministic and they can fail. So it's a good idea to separate pure functions that can only manipulate data from actions which can interact with the external world. For instance, getUser fetches a user record from the database, so the return type is action of user instead of user. The same goes for greeting, which is an action of unit. However, sum is an FP function, it just adds two numbers together, so its return type is simply int. Finally, encoding action with a trait allows us to treat them as ordinary values. For instance, we can store an action in a variable, or we can put several actions together in a data structure, such as a list. We'll see a bit later why this characteristic is really important. Now, before we move on to the exercises, I would like to review the naming conventions for actions. In Scala, there are several libraries which implement the action class. The most popular ones are cat's effect, Monix, and Zio. Now, almost all these libraries call the action class IO and the execute method unsafe_run. These names come from Haskell, where the IO technique was invented. And even though I believe action and execute describe what they do more clearly, it is probably better to use the conventional names so that you can easily transfer anything you learn in this course to your own codebase, which will most likely use one of these libraries. In summary, today we have seen how to encode actions in Scala. We use the trait with a single method and a constructor with a byname parameter. So it's similar to try and future from the standard library. At the moment, this encoding is rather verbose, but we discuss that soon it will help us to develop a rich and powerful API that will support error handling and asynchronous execution. Cool, so I think it's a good place to stop for now, and the next couple of videos will develop the IO API to make it as user-friendly and as powerful as possible. See you soon.